Thank you for your patience. I'm a little rusty on PowerPoint, but we are all set up and going now. So what this talk is going to be in a few phases. First of all, finding your path, career development in crisis. Well, whenever you have a career transition, generally it is a crisis. So there's nothing new about that. But in this case, we have a super crisis because it's not just for one person or for a group of people, but for the whole world. So, and it's hitting some people a lot more. But at any rate, whatever your situation, I hope that you can find something here. And as I say, there's going to be 3 phases. I'm going to give an overview. Here's the overview. We're going to look, I like to take a historical approach. And of course, the reason is because if you ignore history, you're condemned to repeating the mistakes of the past. And we try not to keep doing that. So we're just going to do a brief look at some of this kind of I looked at some figures who were kind of engineers and beginning of, you could say precursors of today's technological world. Da Vinci and Galileo. And then we're going to look at NASA administrators, particularly just one of them, and look at his career, because we're going to look at careers and draw from them. First, we're going to do the historical, then we'll do NASA administrator, and then I'm going to kind of go into the second phase, which is kind of lessons that I've learned from my own career. So have patience if you don't like history. It might be interesting, and we'll get through that pretty quickly, and then we'll go on to the other stuff, and that will be of particular interest to you. Okay, Leonardo da Vinci started at an age of 14, he went to work for a top artist studio in Florence. There he gained artistic and technical skills. At 20, he had his own studio, painted Mona Lisa and Last Supper. These are very brief highlights. What I'm pointing out is that he was also a very technical person. He drew detailed designs for flying machines and for helicopters. At 50, he became an architect and engineer, a military architect. He wrote the Codex on Flight of Birds, which is essential for understanding aerodynamics in flight. So at 50, he only lived to be about 60 years old. So at 50, he became a military architect. And actually on his deathbed, he regretted that he hadn't stayed with his painting. Of course, he's well known as a painter and as well as an inventor. And one interesting thing is that Mona Lisa was never finished. So sometimes your best things may be things that you haven't finished. Who knows? Galileo came a little bit later than Leonardo, although they both were in the same era. They were both had the patronage of the Medicis, different times of the Medici family. Back in those days, I mean, you had to look to where the support could come from to be an artist or inventor or someone who wasn't a physician, had to have some kind of means of support, some kind of means of patronage. This is a little bit of history. Galileo was at University of Pisa to study medicine. His observations of the pendulum and a lecture on geometry led him to study mathematics and natural philosophy. Galileo was someone who would look at things, think about them, and draw conclusions. He wrote the essay on his foundation work in scientific method. With his telescope, he was first to observe the moons of Jupiter and phases of Venus. Dialogue concerning two world systems, he defended Copernicus's heliocentric theory of heliocentric theory. Here's a view of Galileo. Galileo didn't come up with the idea of using a lens to see distant objects, but he did quite advance that, and he had a different design. Huygens was one of the first to make a telescope, but Galileo modified it and actually started using it for astronomical observations. These are some of his observational notes on the 4 moons of Jupiter. Central to his espousing of the heliocentric theory of Copernicus was his observations. And these are some of his notes. Here we see the Milky Way. Galileo, typo there, the Milky Way is made of stars. Before that, without a telescope, the Milky Way was just a bright patch in the night sky during the summer. But Galileo was the first to tell us, well, those are really stars there. That's our galaxy. He didn't organize it into a galaxy as such, but this is a modern picture. This is something that we can learn from Galileo was ethics. Engineering ethics is very important, and it's an essential part of any career. It's going to be a part of transitions for sure. So this gives us some of the timeline. Galileo taught mathematics, University of Pisa, that was his home. Well, that was a big town here, but then he went back to Padua because he had to take care of some family matters, and he got a post there in the University of Padua. Galileo published his findings which were linked to other observations and mathematical developments from Tycho Brahe and Johannes Kepler, which altogether supported Copernicus's theory. Then he linked the tides of the Earth to the Earth's motion relative to the moon and the sun. A dispute with a professor of mathematics at Collegio Romano over the nature of comets started a long problematic relationship with the church. The Inquisition ordered him to not to deny geocentrism. So he turned his studies to other things and muttered, "But it moves," regarding the Earth. This quote shows up on paintings that were done at about that time of him, or a little bit later. So that's his noted quote. He was somewhat of a rebellious person, or maybe he had been kind of bottled up for quite a while. but a friend of his became Pope, and he was emboldened to publish his views again, and maybe got a little bit overboard with the sarcasm because he referred to one of the characters as Simplicissimus, and some of the people who were his intellectual enemies, thought he was mocking them by calling one of his characters Simplicissimus. The Inquisition sentenced him to jail, but he was commuted to house arrest until his death. While confined in his home, he wrote 2 new sciences on kinematics and material science. So Galileo was a person who had his fingers in many pots, you could say. Now, moving to current day, I selected the NASA administrators, and this shows a chart where it shows a number of days served. And this is not everybody, but these are the top ones, plus Michael Griffin, who wasn't in the 2,000 to 3,000 range, but he's an interesting person with some lessons to learn. I don't think we'll get to that today. However, Daniel Goldin was there for 3,500 days, and he was the longest serving NASA administrator. So we're going to take a look at Daniel Goldin's career. Born 1940 in New York City, went to CCNY, got a bachelor's degree in mechanical engineering. 1962, he joined NASA's Lewis Research Center in Cleveland, Ohio, worked on electric propulsion systems for human interplanetary travel. Now, back in the 60s, that was a very advanced, far-thinking thing, electrical propulsion, because this is something that just in the early 2000s, this was something that was being actually developed and built at JPL. So this was 40 years prior that he was working on it, but he left after a few years at NASA and went to TRW in Redondo Beach, California. And from 67 to 87 was an advanced technology researcher. He led the development of Compton Gamma Ray Observatory and the Chandra X-ray Observatory. It didn't get the name of Chandra X-ray Observatory until later, the late 90s, and but it's known as that now. And looking back, we can call it that. TRW was prime contractor, and so he was involved in the early work on that. From 87 to 92, he had risen to vice president and general manager of TRW's Space Technology Group. In 92, he was appointed by George H.W. Bush to be NASA administrator. At NASA, he managed reduction of NASA's share of the federal budget by 28% over 10 years. And the catchphrase back then was faster, better, cheaper. Now, studying Daniel Goldin's life, you got to look into perspective of what was going on there. And he had, for 25 years, he worked at TRW and went from engineer to researcher to manager, to top manager of a large space and technology group at Redondo Beach. So in his environment during that time, this was after the Columbia disaster, and there were things going on that demanded the budget. So I don't think that he actually may not have wanted to reduce the budget by so much, but as a manager, he had the skills to manage that reduction. And most likely this reduction was forced from outside. There was military operations going on in the Mideast and a lot of other things going on that demanded the budget. And so he did reshape NASA, but one of the nice things for jet propulsion and laboratory here locally is that there was a much bigger share for space science than for human flight. Johnson didn't get quite as big a share as they had before. It had been very big, but it was decreased during his time, and a lot more went to space science and to smaller missions, but also to Cassini, which was a large major mission during the time of his reign at NASA. And astronauts went to the space shuttle to install the corrective lens on Hubble Space Telescope, which was a basically going from blind to being the best telescope ever. And he also redesigned the International Space Station. You could say, well, he got the Russians involved, and as you can see, that turned out to work well because Space Shuttle had been around since the 70s, and the equipment on it was, kind of PC type of equipment. People nowadays want to change their computer every 3 to 5 years, but the electronics in Space Shuttle were going for 30 years, and so Space Shuttle had its time, and now we see that the Russians are a big asset, have been a big asset for getting people up to the space station. At any rate, Goldin left NASA and at 2001 and went on to other things. I have a slide back that got out of order. Since leaving NASA, Goldin has been engaged in robotics research at Neurosciences Institute in La Jolla, California. He founded New Edge, formerly Intellisys, produced neural network computing hardware, and served as president and CEO until it shut down in 2018. Now, these are quotes from Daniel Goldin, which give a insight. My eyesight kept getting distorted. This is when he was a young, just growing up, a youngster. My eyeball kept getting distorted more and more, so I became more and more nearsighted. At that time, if you had a detached retina due to the buildup of pressure on the eye, you could go blind. In the Bronx, you played stickball and basketball and baseball in schoolyards. I wasn't allowed to do that, and I became different than my friends. I was self-conscious. I wanted to be like them, but I was forced by health reasons to be different. So here is the man who went to the highest post in NASA and was leading the space effort for the longest period of any of the NASA directors, administrators. And how did he get there? He couldn't get a shot in the basketball hoop. He had to turn inward, and he adapted. He had challenges in his life, and that spurred him to redirect himself and to study and learn things in science and in engineering. Go with imagination, ingenuity, audacity, explore, discover, change the world, and have fun while you're doing it. Now, this is a great quote and not something that I expected by Dan Goldin. I worked at JPL during the time when he was in power, and there was a big decrease in the workforce there, and so there was a lot of unhappiness. But basically, Dan Goldin was trying to do the best he could in the situation, and people at JPL and NASA had to work in the environment they had. And here you see his go with imagination, ingenuity, and audacity. So this is something that we can all apply to our lives. This shows the NASA budget. And this was, maximum was in 1966. And this is as a percentage of the federal budget. So during Dan Goldin's years, it's went from here down to here, 28% decrease. But this was the world he had to live in. We all have to live in the world, and Leonardo had to make weapons to survive instead of nice paintings. So basically, people have to do what they have to do. Okay, now we're getting to my part of the of the presentation. And key tips here: make friends. The key is interpersonal relationships. I'm going to kind of read through these quickly. And excelling at the job is not enough. Ask friends if you're in a position of making a transition, ask friends from previous jobs, classmates, vendors, anybody you've talked to. Check all your contacts, check in on LinkedIn, connect with old people from other jobs. This is a time where internet resume deluge means you need inside contacts to find openings and to push for you. Any company that puts out a posting on Indeed gets thousands of resumes coming in. So you really need to have somebody inside. You need to have connections to get there. This is going to be this is probably the main takeaway from this presentation is it's not technology, not only technology, it's really your relationship with other people that is going to determine your path and should be a key to choosing your path. Another thing is to do what you like. If you take a role that you hate, you may find yourself cast in that same role repeatedly. Managers ask, who did this last time? For a new project, they always want to repeat the lineup they had on the last successful project. They don't want to have something going on that, they're not going to take, they don't want to try new things. Managers, project designers are conservative. They want to make sure they have success. So it's a gamble to go with someone new. Maybe sometime you'll get in on a gamble and get to a new role. But point is, try to find things that you like doing, because if you don't like it, you may be stuck there for quite a while. There'll be more about that point later on. And a job discontinuity is a perfect time to rethink your role. Always consider what training you need for your next role. Be prepared for transitions, because we're in a time of great change. Technology is mushrooming and things are always going to change. That's the one thing you can be certain of. Technology has changed dramatically. We all are aware of that. And the best thing you can do is be prepared. There's change coming. So what I like to say is look ahead. Plan your next transition. Don't let it catch you off balance. There's always going to be some new transition. Okay, play the tuba. Now, you find your niche, an essential but maybe less glamorous job. In high school, back in my days there, people were playing electric guitars maybe, or these were the glamorous things, but a tuba was, I have a nephew, he studied tuba in high school band, college band. He traveled all over with the teams and made friends. Very important part. You get to enjoy life a little bit and be part of something bigger and see the world. Okay. Another example of this is in jobs, not a tuba, but power supplies. I came from computer industry and actually for a while I worked on computer power supplies, and this is not maybe glamorous. Glamorous would be, processor, fastest, best processor chip, but power supplies are kind of a steadfast, long-running, for sure thing. This is someone who goes into power supplies as, it's not maybe a huge market like programming or, best design architect or something, but power supplies is a very stable field, and a field where there is new ideas. People look at it, you can be inventive. I know someone who came up with a new power supply idea and got a patent, and he's got a very good position at a very good company. And think about things that you might not want to take a second look at. Think about things that you might shy away from. Sometimes you find that, well, for survival, at times you have to make some decisions. You have to pick things that you might not think as the best things. This is opposite of what I said earlier, but this is for a different environment. If you have a job, you're trying to get on a project, they're looking for people with certain skills or whatever, different roles. That's where you have flexibility, and you want to find a role that you enjoy. Sometimes when you're kind of caught in free fall, you have to grab whatever parachute you can grab onto. And that's why I say here, reconsider what you may shy away from And don't be afraid to make changes there. This is about, this is, always use the camera strap. I've got these little phrases to convey an idea. One time, my wife and I were walking in a nice environment. We just got out of our hotel, and I think I had the camera and she wanted to take a picture, and so I tried to pass it to her, or no, she was passing me. I'm not sure what was the exact situation, but procedures are to protect you and to help you produce quality results. Follow the procedures and don't take shortcuts because they lead to costly errors. Rerun verification after all changes. So main thing here is be careful. You follow procedures. Now, I'm not saying to not innovate procedures, come up with a new idea procedure. That's great, but say there's a slight crack and things not working. That's not a time to innovate a procedure. That's when you have to follow the existing procedure. Innovate a procedure when you have time, sit back and think about it, try things, not in a crisis mode. Show your work. This is something you may have heard from your teachers in grammar school, high school. Well, this applies today especially. Write technical reports, publish papers at technical conferences, attend workshops. Professional societies have workshops, which are not quite conferences, but they're more informal, and there's a time to get to know people, talk to people, make friends. Talk to people. You're going to meet people, which be your next connection to another job, possibly. Participate in technical organization. People always complain about organizations, but the truth is that organization, nobody really wants to do a lot of work in an organization. Who gets to be a leader of an organization? People who are willing to do the work, people who are willing to push themselves a little bit. And point is here, if you don't like an organization, get involved in it, work in it, make it better. Ask your former boss what innovations may be disclosed. Sometimes this doesn't apply in a secret environment, but in industry where there's trade secrets and so on, if you come up with new ideas, innovations, a lot of companies are extremely protective, but in some cases, for one thing, back at IBM, they would like you to, well, basically the first thing is if you can get a patent, get a patent. But you can do a disclosure, and that's in a sense protecting against someone else patenting it. So there may not be a patent, but there could be a disclosure. And the disclosure is something you can reference, that you came up with an idea, and it's something you can put on your resume. So, but in organizations, there are technical reports. Write a technical report. Ask your boss, because in industry, you may be surprised, as I was, that something that you think he wants to keep trade secrets, maybe they're not too, maybe they're open to telling about what you did. People want you to get the benefits of your work. You've come up with something, show your work. Try to, don't try to show other people's work. You work in a team, write a article for a magazine, for one of the technical publications as part of a group. Don't antagonize people by being the outsider who comes in and writes something up and kind of shares the public, grabs the public credit. You have to follow the procedures of the company and also the ethical procedures of giving credit where credit is due. Okay, become a dentist. Now, this is something you didn't expect to hear here, but back in engineering school, my lab partner had no intention of becoming an engineer. Maybe this is by the time of senior year, I'm not sure, but whatever his intention at the beginning was, but he went on to become a dentist. That's what he wanted to do. And your talent may be in a totally different field. People do make transitions, and I've known people who study mathematics, go into physics, and I know programmers who go into engineering. So don't be afraid to explore new paths. Explore, in fact, just as while you can, if you're employed and you have time, or if you're not employed and you have a lot of time, just view webinars, try to pick up as many skills as you can. There's a lot of free online courses on YouTube, videos, and you should always be developing, as I've mentioned, to look for whatever's coming next and to try new things. And here it is, Reinvent Yourself. Freeman J. Dyson, who wrote a lot of books about string theory and physics, and had many different roles in life, including engineering. He says, he came and talked to us at JPL, and he said, I need to start a new career every 4 years. So he would, people might think of life as a steady arc through life, but really it may not be that way. Maybe more like traveling on subway in New York City. You jump off one train, get on another, go in opposite, different direction, or orthogonal. In your life, you may find that you're going off in many different paths, but that gives you a chance to try new things and to grow. And basically, in today's world, what you thought would be there in 10 years or 15 years or 20 years very likely won't be there. And there's going to be something else, and you've got to keep jumping and adapting. Okay, make a violin. Now, I'm in a technical group. This was kind of old timers. And I was invited to visit a garage violin workshop. This is down in Redondo Beach area. And surprise, guy who works at one of our companies down there was interested in violins, to construct violins. He isn't necessarily a musician, I'm sure he fiddles around with it a bit, but just the beauty to make something and to apply modern technology in a new way, to emulate something that was done 400 years ago, in a sense, and this it's an opportunity to interact with other people because there is a group of violin makers and they have a magazine. And main point is there's life outside of work. Develop your interests. It will preserve your sanity. If you are one of the people who never takes a vacation, when you do have a chance for a vacation, you should do it. Wheel of life. So, wheel of life, kind of, what I'm thinking of here is there are cycles in life, and I'm going to describe some of them here from my experience. I got involved in computers when I went to a big company. I went to I/O. I had started with processors and computer arithmetic. I didn't really think of I/O as exciting, but I did, this was my first handhold in climbing that mountain in a sense. And so I got in, I learned to do things. I worked on some little projects, which surprisingly foreshadowed other things that I would see later on. In later life, years later, this refers to this, I would be a lead engineer to take in data. We had a parachute test technology. We instrumented the parachute test for Mars landing. And Pathfinder had been a very light, small thing, size of a shoebox. Next thing was going to be the size of a Volkswagen. This was the MER, Spirit and Opportunity. So we had a high altitude subsonic parachute project, which was this wasn't a space project. This was a quick technology thing that I was doing as part of avionics to instrument this balloon payload that would go up to 100,000 feet to the top of the stratosphere and come down, plummet until it got to where atmosphere would be thick enough for a parachute to work. And well, the whole idea was to simulate what's going on at Mars. Gravity was going to be much worse here, but at certain parts of the atmosphere are similar to the Martian atmospheric density. So, point is, what I was doing in that was to bring in data from several different instruments, taking account GPS, IMU, which is basically gyroscope, and thermo sensors, pressure, barometer, all this different data at different rates. So I was engineered to bring that all together and kind of package it. We had 11 hours of data we had to capture, and we did capture it. But the point is that from I/O design, which I didn't really want to get involved in, but did get involved in, I ended up doing I/O design, say 35 years later. So it's a wheel of life, it's a circle. And then even after that, at JPL, I went on to be a consultant, and I was doing custom IP, intellectual property in that was custom IP is a little bit of hardware that we designed to do something that's not available off the shelf from the library. And so I would do custom IPs, which interact with a processor on the chip. So back from the old days of many, many chips, here we go to lots of things being on the chip. Okay, now, besides this kind of circularity in terms of technical topics, here's a situation where my boss, I worked at a company in Boulder, Colorado, which kind of dissolved that. They shut down that facility. And so this was a computer company, and I went on to work at IBM, as I mentioned, and was there for 6 years. And at IBM, I had a great time, but I never expected to leave. But I got a call from my old boss, and he had an instrument in me, and which saved me a lot of aggravation and money. So I really owed it to him to come out to San Diego and check a startup company. I had to come out to San Diego and check a startup company. So that ended up in my transition from East Coast to West Coast, where I've been here for a good many years, over 25. So point was a connection from the past, blast from the past, made instrumented this transition to a new job. Another personal connection here is I had a working at JPL, designing some chips for the deep space network, some ASICs and gallium arsenide. So I had a summer student come. Well, I had a new engineer, first of all, who was a full-time, and I did kind of train her and, you know, advise her in some new skills, and she went on very successfully and became a manager. Well, I stayed in the engineering path, the technical path. She did become a manager and was someone that I could, in some cases, to be a resource years later. I'm talking 15 years later. So then there was a summer co-op who again, at JPL, somebody was working in another group as a summer student and wasn't getting along. He was being treated terribly by the guy he was working for. And so he came over and I gave him, gave him a shot and kind of got him going on doing some electronic design. And when he went on, well, actually, years later, I was sitting in a cafe and somebody comes up to me and says, Jim Kowalski. And this was a time of transition for me. I was sitting in a cafe and having lunch, and there he is, the summer student from 20 years before, and he's telling me about what he's doing at a company that's expanding in the area that needs help. So I did go and interview there, and point is that where you least expect it, things can come back to you. And again, one more kind of technology thing. these letters here may not be familiar to you, but JTAG was stands for Joint Technology Action Group, and this is something that for testing electronics they came up with an idea called boundary scan, which basically it's turning you could say a city of houses into more or less a pipeline. If you think of a railroad train, all the cars are connected. That's the scan path. And so you have an extra path on everything, scan data in, scan data out. This is a way to test the chip. And back at JPL, there was a guy who, this was before this JTAG became something that is an off-the-shelf library item. We were using it to test our ASICs, our special custom designed chips. And so we did have boundary scan, which was the kind of railroad car serial transfer on the boundaries, which actually it's like taking the chip off the table, off the board, and putting it down onto a test apparatus. You can scan in, scan out, you can apply stimulus, you can look at results. So this was something that we used for testing the chips, but we wanted to incorporate that. We had somebody who had been working on, works with a state machine for JTAG, and again, this was before this was available off the shelf. So I took over this project from somebody who didn't finish it for one reason or another. And I did get the state machine working, and this was an early FPGA from Xilinx, and now it's kind of a standard issue now on these chips, I think. So point is that technology goes around. I was back at IBM, I was involved with that. And then again at JPL, and now it's everywhere. So this is the wheel of life. And just one more thing. Every mission needs ground support. And I want to give, there's infinite thanks give to my wife, Hilda Pirelli. And here I go up to, on top of a huge area, climb up and just view the comet, and she stayed below, but every mission needs ground support. And personal relationships, as I told you from the beginning, personal relationships are essential. They're the key. They're the most important part. Technology is something that we're all working on, but you've got to focus on the human side. And now we're ready for questions.